This is problem 1 of homework 11. The stochastic process xt is the real WSS with autocorrelation Rxx tau, and the power spectral density is xx omega. Show that for part A, Rxx tau is real and even, and for part B, Sxx omega is even and non-negative. So for part A, Rxx tau is equals to expectation of xt plus tau times xt. So it can prove that Rxx tau is real. And Rxx tau equals to Rxx t plus tau t equals to e of xt plus tau times xt, and Rxx negative tau equals to Rxx t plus tau equals to e of xt times xt plus tau. So we can get Rxx tau equals to Rxx negative tau. Thus, we can get Rxx tau is real and even. For part B, Sxx omega equals to integral from negative infinite to infinite Rxx tau times e to power of negative j omega t dt equals to integral from negative infinite to infinite Rxx tau times cosine omega tau d tau equals to 2 times integral from 0 to infinite Rxx tau times cosine omega tau t tau. Sxx negative omega equals to integral from negative infinite to infinite Rxx tau times e to power of j omega t dt equals to integral from negative infinite to infinite Rxx tau times cosine negative omega tau d tau equals to 2 times integral from 0 to infinite Rxx tau times cosine negative omega tau d tau. So we can get Sxx omega equals to Sxx negative omega. So to prove non-negative, we need to set xt to h omega to yt, and we need to set h omega equals to 1 if omega 1 is smaller than omega 2, and otherwise h omega equals to 0. So we can get e of absolute of yt square equals to 1 over 2 pi times integral from negative infinite to infinite times absolute h omega square times Sxx omega d omega equals to 1 over 2 pi times integral from omega 1 to omega 2 times Sxx times sorry, it's repeated. So we can get is it equals to 1 over 2 pi times integral from omega 1 to omega 2 times x omega d omega. And we can get the e of absolute xt squared is larger and equal to 0. So we can get s x omega is even and non-negative.